Welcome to section 2.3, day 1, rules for differentiation. So today's objective is to differentiate functions using the power, product, and quotient rules. Today we are going to learn shortcuts. Instead of having to do that full limit every time to do derivatives, we are going to learn the quicker method on how to do these. So the first one we're going to look at is the power rule. And it says derivative with respect to x of x to the nth power is n times x and raised to the n minus 1 power. So with the power rule, what we do is we take the exponent, bring it out front, and then subtract 1 off of the exponent. So when we have y equals x to the 5th, 5 is n, so we bring 5 to the front, and we get x to the 4th power, because we take 5 minus 1 and we get 4. If we have x to the 4th, again, we bring that out front for the n, and then our variable is x, and then 4 minus 1 is 3. For x cubed, we bring the 3 out front, we subtract 1 from the exponent, and we get 3x squared. For x squared, we bring 2 out front. 2 minus 1 is x to the 1st, or just 2x. And then x to the 1st is just 1. This is the power rule. So basically, for the power rule, you take the exponent, bring it out front. If there's a coefficient already there, you multiply them together, and then subtract 1 off the exponent. That is our power rule. So here is the power rule again. Now we have 8x squared, and we want to find dy dx. So when we do this, we also need to make sure we use proper notation to show that we're doing this. So the derivative of y with respect to x, we take 2, bring it out front. 2 times 8 is 16. 2 minus 1, x to the 1st power. So derivative of y with respect to x is 16x. For this one, we have 7 over x to the 7th. I recommend you rewrite this into 7x to the negative 7th. Then we can take the derivative, and we take negative 7 up front. Negative 7 times 7 is negative 49. X to the negative 8th, because we subtract 1 from the exponent. We can rewrite this again if we want, and we get negative 49 over x to the 8th. We move that negative exponent. Now we have y equals negative 1 over x to the 6th. Again, I recommend you rewrite this. And when we take the derivative of y with respect to x, we get 6x to the negative 7, which is 6 over x to the 7th. And then whenever we take the derivative of just a number, a constant, the derivative of a constant is 0. You could look at this as being 4x to the 0. Well, if you take 0 times 4, you get 0. So dy dx is just 0. So if there's ever a constant by itself, the derivative of the constant is 0. Next we're going to look at is the sum and difference rules. So if it says we want to take the derivative with respect to x of u plus or minus v, so u plus v or u minus v, u and v are just two functions, or two pieces of a function. Then we just take the derivative of the first and the derivative of the second. So when we have this y equals 3 plus 2x to the 4th minus 10x to the 6th, all we're going to do is take the derivative of each piece. So dy dx, we already talked about the derivative of 3 is just 0. 2x to the 4th, we use our power rule for this part. So we take 4 times 2, which is 8. We subtract 1 off the exponent, we get 3. So now we have 8x cubed. The next part, we take negative 10x to the 6th. We multiply by 6, we get negative 60x. Subtract 1 from the exponent, and we get 5. So dy dx is 8x cubed minus 60x to the 5th. The next one we have is we have x plus x squared over 3 plus 2x to the 5th over 5. We take the derivative of each piece separately as we go across. So dy dx, derivative of x to the first power is 1. And we subtract, we get x to the 0, which just also goes to 1, so we have 1. This is going to be 2x over 3. We bring the 2 out front, and we subtract 1 from the exponent, so we have an exponent of 1. So we have 2x over 3. And then we bring the 5 out front. 5 times 2 is 10. 10 over 5 is 2. And this is plus 2x to the 4th. So there's my derivative using my sum and difference rules. All we're doing when we do the sum and difference is do each piece by itself. In this case, we're using the power rule as we went across, and that is how you take the derivative using sum and difference rules. The next one we have is the product rule. This is where you're going to start wanting to use some note cards to remember these things. To do the product rule, if we have two functions multiplied together, both have variables in them, you take the first part times the derivative of the second, plus the second times the derivative of the first. So what does that look like? So here we go. First times the derivative of the second, plus the second times the derivative of the first, like I just said. So here we have a couple of different functions. We'll look at the first one. We want the derivative with respect to x of 2x cubed and x squared plus 5. So like it says, we take the part of the first by itself, which is 2x cubed. Derivative of the second, we have x squared plus 5. If we take the derivative of x squared plus 5, we get 2x to the first power. The 5 goes to 0. And we add that now to the second piece, x squared plus 5, times the derivative of the first, the derivative of 2x cubed. If you take the power rule, you have 6x squared. We can now simplify this, and we get 4x to the 4th plus 6x to the 4th plus 30x squared. Combine our like terms, and we get 10x to the 4th plus 30x squared. So dy dx equals this. That is our product rule in work. The next one we do is the same idea. We take the first part, x squared plus 2x. We multiply it by the derivative of the second, and that is going to be 4x cubed. And then we add the second part, x to the 4th minus 7, times the derivative of the first, which is 2x plus 2. We do those power rules. And then we multiply everything together, and we get 4x cubed and x squared is 4x to the 5th. 4x cubed times 2x is 8x to the 4th. Then we do 2x times 4x, or x to the 4th is 2x to the 5th. And then x to the 4th times 2 is 2x to the 4th. Negative 7 times 2x is negative 14x. Negative 7 times 2 is negative 14. And then we go through and combine all our like terms. We have a 4x to the 5th and a 2x to the 5th, so we have 6x to the 5th. We have 8x to the 4th and 2x to the 4th, so we get 10x to the 4th. We have a negative 14x and a minus 14. So dy dx is 6x to the 5th plus 10x to the 4th minus 14x minus 14. That is demonstrating how to do the product rule. You take the first times the derivative of the second, and then the second times the derivative of the first, and add them together. Next, we're going to learn the quotient rule. The quotient rule is low d high minus high d low over low squared. So what does this mean? It says take the low function times the derivative of the higher one minus the high times the derivative of the lower one, all over the lower squared. So let's see what that looks like. We have derivative with respect to x of x squared plus 12 over 3x. So we're going to use our low d high minus high d low over low squared. So our low is 3x. Derivative of the high one, x squared plus 12, we take the derivative using the power function, or power rule, and we get 2x. Then we minus the high one, which is x squared plus 12, times the derivative of the lower one, 3x, the derivative of 3x is 3, all over the lower function, 3x squared. So when we do this, we get 6x squared. Then we subtract, make sure we keep our signs. 3 times x squared is 3x squared. 3 times 12 is 36. All over 9x squared. And then we continue simplifying. We get 6x squared minus 3x squared minus 36 all over 9x squared. Combine like terms, we get 3x squared minus 36 all over 9x squared. We can divide a 3 out of everything, so we get x squared minus 12 over 3x squared. This is my derivative with respect to x. So we have x squared minus 12 over 3x squared. This is the quotient rule. Remember, the low times the derivative of the high minus the high times the derivative of the low over low squared. Again, with these new rules you're learning, these shortcuts, I strongly recommend you start using note cards to learn these rules. We have more to come. Today we looked at the product rule, we looked at the sum and the difference, we looked at the power rule and the quotient rule. The last slide we have today is finding horizontal tangents. So it says our tangent would be horizontal when the slope of the curve at that point is what? Well, when your slope is 0. So to find whether tangents are horizontal, find the derivative with respect to y, with respect to x, and set it equal to 0. So take your derivative and then set it equal to 0 and solve it. So here we have 2/3 x cubed minus 2x squared. We take the derivative using the product or the power rule, and 2/3 x cubed, we bring that 3 to the front. 3 times 2/3 is 2, and then we subtract 1 from the exponent, and we get 2x squared. The next one, we bring the 2 out front, we get -4, subtract 1 from the exponent, and we get -4x. We then take our derivative and set it equal to 0. So we get 2x squared minus 4x equal to 0. Factor out a 2x, you get x minus 2 equal to 0. And then you set both factors equal to 0. And x equals 0, and x equals 2. So there are two places where we have a horizontal tangent for this, which makes sense. This is a cube function, and we have two different flat spots, two changes of direction where the slopes would be 0, and they happen at x equals 0 and x equals 2. If it actually asks you to write the horizontal tangent at that point, you would actually find your y values and then write your equations. That is all for section 2.3, day 1. Today, we have learned a whole bunch of different rules for finding derivatives quickly instead of having to use the formal definition. Make sure you show your work when you're doing your assignment. Thank you for watching, and have a nice day.